We're on.
Who's starting first?
I do, and I'll be calling calling you by name when it's your turn. I'll invite you to speak.
Okay.
Okay.
Okay. Thank you.
Good morning and welcome. Hello. It's 9 o'clock. We're ready to go. My name is Judy Farvolden. I'm the Executive Director of the University of Toronto's Transportation Research Institute, and I will be your host and moderator for this session, which mostly means just keeping our excellent speakers on time so that we have time to hear from each of them and time for your questions. In this session, our speakers we will hear from 3 operators: Société de Transport de Laval, the New York City Transit Authority, Metro Transit-Minneapolis, a recent graduate of the University of Waterloo from Computer Science 2020, congratulations Eddy, and Lynxx joining us from Sydney, all sharing their stories of the practical ways data is being used in service planning and operations. As we said, living the dream. I have a few housekeeping remarks. Remember that the presentations either have been shared or they will be shared and available for download from the links on the final program page posted at the Union Hub. You know as well by now that there's no live Q&A planned for these presentations, so please post your questions in the Google Drive Q&A document that you found either on the Union Hub page, and there's a link to that in the Zoom Q&A. We won't be using the Zoom Q&A for questions, but there you will find a link to the document, and please post your questions there. And remember that there's a tab for each of the talks in this session. So look along the bottom and find the tab for the talk, and then please post your question, and we will find time to come back to the questions at the end. We won't take questions we'll take questions at the end. And this session is being recorded. So now I can welcome Burt from Lynxx to unmute and share his screen and begin his presentation.
Hello, everyone.
We see you and hear you. Off you go, Matt. Thank you very much. Ryan.
I'm Ryan. I work for a company called Lynxx. We're a data analytics consultancy firm. We specialize in transportation and logistics. We have offices in Australia and the Netherlands. We have significant experience in using real-time open transit data in production environments. We've bundled several processes together into a suite of tools which we call ops, and this will be the framework for my presentation. Our work has forced us to address the practicalities and challenges involved in using both open data and enterprise data combined. So for this presentation, I'm going to try and explain some case studies in terms of inputs, calculations, and challenges and outputs. So what have we had to deal with? First thing, and this can't really be overstated, is that real world data is messy and it causes all kinds of complications. For example, standards such as GTFS, they vary across different regions, and even within a region there are inconsistencies based on different contract areas. Sometimes within a single contract area, you still can't get a consistent set of specifications. Additionally, you have competing specifications where the requirements for processing them are different and not compatible, which further complicates your own processes. Sometimes you're dealing with data such as a headway system, and it doesn't really match with a regular timetable for the concept of something like a trip ID. Other cases, you have to account for data which is missing, but a real event has occurred, such as a cancellation or an added service. And this makes tracking a specific vehicle or trip difficult, or getting accurate KPI information without errors. So I'm going to briefly discuss two case studies. The first is for the Sydney Ferry operator. They had a requirement where they wanted an output of live KPI information inside their control room. In this case, the input was AIS marine radio data combined with public open timetable and the operator specific vessel allocation data. So the difficulties we had here were we had to design an algorithm which could handle inputs where the variability was very high and the usability was quite unreliable in certain cases. So just as an example, on the left here, this is vessel tracking based on a AIS input, and you can see that there's only a very small number of points. On the right is the same vessel in the same time span, but it's based on specific GPS tracking software. So our algorithm actually had to be able to account for both cases and try and provide accurate information for real arrival time or real departure time. So we managed to achieve this by using some probability-based models based on the vessel speed and vicinity to geofence and change in its state. Second case study is for Auckland Transport. They had a requirement for predicting arrival times for their entire region. In this case, the input was a live feed of GTFS RT data. So we also had to produce a live feed out of GTFS RT data. The difficulty was that we were required to provide high quality predictions in a very high frequency and a high volume, and also maintain a large number of models in a production service. Our particular solution in this case to fulfill those requirements was to provide a base level of accurate predictions using linear regression models, and then have a layer on top where we could deploy a more bespoke and nuanced set of predictions based on very specific targeted areas which the client identified as interesting to them. So what have we learned from our experience over the last few years? The first thing I would want to say is that flexibility of input processing is very, very important, because it sets up all of your downstream work. So if you've built a system or a process and it's based on real data from one region, when you go to apply it to a different region, the chances are that it's not going to work out of the box without errors. And it's important that you give it respect, because sometimes the errors are quite hard to detect, yet they will give noticeable permutations through your analysis, and you can actually introduce some invalid data. Another thing we've learned is that you can make up for imperfect data with big data. And by this, we mean that if you collect as much as you can, if you accumulate millions of points, you can actually identify long-term trends, which you can then use to build a picture of what's most likely to have occurred. Additionally, you should try and utilize probability in your algorithm.
1 minute.
If you're lacking the exact data points that you need. Now, the reason for this is that if you use probability, you can give an answer which is maybe the most likely result, and sometimes people will be more interested in hearing that than they will hearing no result at all. Finally, what I want to say is that extreme transparency is very important, and by that I mean you should try and make your data viewable to the greatest level of detail that you can. You should also display the performance of your models and algorithms so that they can be criticized. You should discuss weaknesses and assumptions in your logic. Now, the reason for this is that it builds trust in the tools that you've provided, and it actually drives continuous improvement, which helps yourself It helps others understand what the difficulties that you're going through are. Finally, you should use the knowledge that you've gained to enhance other parties' understanding of the data, which enables them to make decisions for themselves more effectively. Thank you.
And thank you, Ryan. Please remember to post questions that will come to after at the link that you find in the chat box. And we'll move on. Thank you very much. Our next speaker is Florian Sis. Florian, I invite you to unmute your microphone. Share your screen.
So here we go. It's a video.
And we hear you and see you. And thank you. We're ready to go. Thank you.
Okay. So it's a video, 6 minutes, 28 seconds. You have to adjust the sound for it. Hope it's going well. Hi everyone, and welcome to this lightning presentation about troubles in a bus station and how we've been tackling that issue with AI in an innovative way. I'm Florian Sis, and I will be presenting with Gregory Wielinski. First of all, we are in unprecedented times of pandemics, but do you remember the last time you've been in a bus station? More precisely, I'm talking about times when buses have difficulties to move around terminals during peak hours. For those who might not have never witnessed that moment, here is an example of what it looks like. And we have to imagine that transit will keep growing in the future. In order to solve that problem, first we had to retrieve data. Hopefully we've got 1 billion GPS reports a day, and then a solution to retrieve useful insights from them. We're looking at arriving and boarding times and the difference between parked buses and buses taken in traffic jams. And we found one solution. We call it TerminalNet. But exactly who we are, in fact, we're data scientists in the planning department of STL. It's a small transit agency in the city of Laval, located north of Montreal. It's around 46 routes with more than 300 buses and 1,000 employees, and we move 20 million riders per year. Our job, in fact, for more than 10 years right now, we've been searching, developing, and maintaining solutions to extract insights from data collected on buses and other sources to drive action. In order to develop that solution, we've been looking at artificial intelligence. Gartner had identified that technology as strategic for at least the past 4 years. But what about applications already done for transit with it?
The problem with the literature is there's no literature on general GPS classification, so we have to find another literature to base our research on. So we find the trip mode classification to be a good substitute. Usually rule-based algorithms are used in this field of study, but more recently more advanced techniques as deep learning methods were used, as with the work of Jan and Alla and Debury and Alla. We use both the CNN and the RNN neural network classes in their work. So for example, the CNN for convolutional neural network are more used in image processing, so they try to extract high-level features from images, while RNN for recurrent neural network are more used in sequence processing. So in this research, we wanted to use both to accomplish a better extraction of spatial temporal features to have a better model called TerminalNet. So the goal is to develop a solution to split a sequence of GPS points of a bus between its arrival and its departure from the terminal. 4 main activities are predicted, so the bus moving around, the alighting, the bus parking or waiting time, and the boarding phase. Standard cleaning steps were made, but the particularity here is that we have to compress or expand some sequences to produce the same length for all sequences. In total, we produced 45,000 examples for our training phase. On tensor creation, we have to do 2 tensors, one for the CNN and one for the RNN. In total, we use 156 variables, mostly discretized variables based on X and Y location, the speed, and the door opening of them. This is the architecture that gave us the best results. We start with 2 convolution and max pooling steps, followed with 3 dense layers. Each layer is programmed to predict if alighting, parking, or boarding activities are present in the sequence. Then we concatenate the results to our RNN tensor to apply a GRU. And finally, the model outputs 4 probabilities, one for each GPS point. So in total, we have 400 probabilities for the whole sequence. The metric used to select the best model is the intersection over the union. With over 9,000 test samples and a cutoff of 75% for our IOU, we had an 86% success rate. On actual results, the model could really well split the sequence into all 4 activities, but what is more spectacular is even if we had made minimal data cleaning, the model could predict really well even if the GPS drift is present in the data, as presented in this picture.
To conclude, AI was able to solve our problem, but we've learned that it needs to train on clean and huge datasets that you have to prepare. Then you have to test various algorithms and adapt inputs in order to use the tools correctly. For the future development of TerminalNet as a solution, we have to reach operational activity with a daily analysis of the terminal activities, but we also have to extend that analysis to other bus stations. In terms of use, AI is a powerful tool for transit agencies too. It comes with delays to prepare clean datasets to learn from, but tools are going to be more and more available in the future. We're at the end, so thank you everyone, and special thanks to Transit Data for having me.
Thank you very much, Florian and Gregory, for your presentation, and we'll move on next to Eddy Ionescu from the University of Waterloo. Eddy just graduated from computer science. Congratulations, Eddy. We can see you, and I'm going to invite you to share your screen and your presentation up, and off you go. Great.
Perfect, thank you. Good morning, everyone. So hi, everyone. Today I'm going to talk about connecting to the GO train. GO Transit is a commuter rail service in the Toronto area. Highway congestion was getting really bad, and so the province of Ontario decided to try out an alternative to widening highways. They decided to offer a commuter rail service meant to get cars off the highways by parking at stations instead. But expanding parking at surface stations is no longer viable, and parking structures, of which several have been built in the past decade, are really expensive. But despite most customers driving and parking at the station, close to half said they'd be willing to take local transit to and from their station. It's just not convenient enough. But now, ridership growth is constrained by parking. There has to be a mode shift to accommodate projected growth. I'll be focusing on local transit as it's the most scalable option and has been proven to work in suburban areas in the city of Toronto and elsewhere. Before we attempt to shift the mode share, we first have to ensure that it's a viable alternative for GO customers. My research focuses on determining whether it's a viable alternative or not. There are many different factors, all of which can be quantified from various data sources. With GO trains running every 15 to 30 minutes in peak periods, reliability is extremely important. You won't take a bus to the train if your bus is late every few days and you end up having to wait up to 30 minutes to catch the next train because you missed the one that you wanted to take. Stations, which are both at about 100% of parking capacity, with different levels of land use around their stations. For each station, I'll be looking at one local transit route that serves a nearby residential neighborhood, nearby but outside of walking distance from the station. Being in a walkable area Port Credit has one of the highest walking mode shares in the network. For this station, I'll be looking at the Cawthorpe Park neighborhood, starting at the Star as the origin and taking the 8 bus to Port Credit to an eastbound train downtown. Being a later suburb, Rutherford Go is not as walkable and transit-friendly as Port Credit Go. For this station, I'll be looking at the Thornhill Woods neighborhood, starting at the Star as the origin and taking the 87 bus to Rutherford Go to a southbound train downtown. In order to compare local transit and park and ride, I calculated their generalized costs. The generalized cost is the sum of the monetary costs, like driving a car or paying a fare, plus the cost of the time spent making the trip, which is valued at $17.96 an hour, the figure Metrolynx uses in their business cases. Buffer times represent the time that schedules don't include, such as the time that a bus could be late by, or the time you spend circling the lot looking for a parking spot because the lot's almost full. Another example of buffer time is having to arrive at a stop before a bus is scheduled to arrive. If a bus sometimes arrives, say 2 minutes early at your stop, that's a penalty of 2 minutes. Google Maps and other travel models don't take this into account. This table shows the difference between the generalized cost of using transit for that trip minus the generalized cost for driving and parking. In early bird, arriving at the station before 7:30 a.m., this time varies by station, you have an easy drive and have plenty of spots to choose from. At peak hour, there's some traffic congestion on the local roads, plus you have to circle around to find a spot, if you manage to find one at all. That's why having a reserved parking spot decreases the generalized cost, even though it adds $2.45 to the cost of the trip. Survey data was used to estimate the number of commuters originating from each of the 2 neighborhoods who go to the GO transit station across all modes. And how many of those commuters took transit to their station was estimated from APC and AFC data. Now we have local transit mode shares that correspond to the generalized costs that are calculated for local transit. This links the quality of a local transit connection to its mode share within a neighborhood, which could be used to predict how changes in bus and rail service would affect the mode share of local transit at each station. I showed that reliability and schedule alignment are critical when connecting to infrequent trains, among many other factors. More frequent rail service will help address this too by decreasing the penalty of missing a train. And it's hard not to notice that it costs $1 to connect to local transit, but nothing to park, it's free. Increasing the cost of reserved parking spots and using that additional revenue to fund free local transit connections would further increase the local transit mode share and allow for more ridership growth as the quality of local transit improves. Lastly, increasing awareness is vital for getting GO customers to switch to, or at least try transit. Using online maps like the one shown here is one potential tool, which I developed last summer to help Metrolynx planners see the options customers have to connect to local transit from each train. There's also an ongoing pilot for adding a map of local transit options to 3 GO stations that are not studied here. Maps, whether online or in person, would help customers become aware of their local transit options and have them consider switching to local transit, increasing ridership growth sustainably as the Toronto area continues to grow as well. Thank you.
Great. Thank you very much, Eddy, for that. And I want to acknowledge the 80+ people who are now joining us, and to remind you, please, to post questions. You can find the link to the Q&A document in the chat box of this session. There's a tab at the bottom for each of the talks. We just finished with improving local transit connections, and we're staying on time, so we will have time to go to your questions. So please do remember to ask questions. Thank you very much. Thanks, Eddy. Okay, next I'd like to invite Alla to unmute. and share his screen. Speaking on transit service visualization. Alla, your video.
Start video. Okay.
Yes. Yes, okay, we see you. Go ahead and share your screen. Over to you for the next 6 minutes. There you go.
It's coming. Okay.
There you are. Good.
Okay, my name is Alla Reddy. I'm from New York City Transit, in charge of data research and development and operation planning. And I have a great team of staff, they're working on something like, transit service visualization in real time. So as we all know that, we carry around 5 million people on a given day, and we have like 600 trains during rush hour. We operate 24/7, and we have 472 stations. So first year, more than 100 years back, in 1904, the system started. So we have a number of divisions like A and B division. A division is basically numeric lines like 1 through 6, and B division we have CBTC lines like L and 7, and rest of the lines, we have it, but there's no centralized monitoring setup, for the control center. So our goal is basically to provide enough detail to show where the problems are. So, and we kind of designed a map, visual map that will display clearly for the whole system. The system we have is very complicated because like A division is centrally monitored from the rail control center, and we have CBTC 2 lines, and for the B division, we don't have any centrally monitoring system. So combining many data sources and displaying on one map is very complicated. So not only we display the trains on a map at the same time, we are doing some analytics based on multiple sources of data and identifying the problem areas, like where they have bigger gaps, like moderate, severe, and very severe. So these things based on the headways, we kind of, did analytics behind and displaying that in real time. So we have multiple stakeholders, internally we provide this map to the communications group. So they relay the information to the public and to tell where the delays or gaps are, so that they can able to rearrange their service changes wherever they want to go. And service managers, like I mentioned, we have A division, they monitor centrally, but for the B division, still old technology, they still monitor from the towers. They don't know exactly where the trains are. They monitor through closed circuit TVs, but we are doing a pilot in a couple of towers, and they are heavily using this map, and they can able to see where the trains are. And externally, we are trying to explore and send it to the customers. Not yet done, but that gives them the better picture where to take the alternate trips, And the potential, this map is very dynamic, and we can able to expand it to any type of mode. We are adding bus mode also to this. So as you can see here, the left side basically we talk about areas with gaps, and we identified the gaps, so how severe it is. So moderate, severe, very severe. So it's all based on the headways. When you're providing service every 6 minutes, if it's a severe, it's like 10 minutes, very severe, like triple the headway, things like that. And we identified alternate colors, and we can able to hover over at the station, and we can tell exactly the schedule gap and the actual gap. So, and on the right side, we have basically congested areas, how fast the trains are going. So here, little bit zoomed version, like stations are color coded, as you can see that, and the running times or the speed, we can able to tell from where to where, how long it takes. And to be more clear, on the left side, very severe, we can tell from station where it started and where it ends, the gaps and start time. And as you can see on the left side, there are current gaps around 12. And it's more visually, we can able to see that. Can also show train locations for most areas as optional map layer, and with the train ID and how long it was updated, basically giving that an idea. I just want to show something more in live. Hopefully it works. So this is the same thing what I displayed in the PowerPoint. Right now, what's going on in New York City right now. So right now the service seems to be pretty good because we don't have anything severe issues, or very severe issues, and most of the trains running smoothly. And we have like around 8 moderate gaps there. I'm going to just click on one of that. That way you can able to see the map of the city, and the gap is around supposed to be like 19 minutes gap. Then it gives a better picture about what's going on in the service. That is on the left side. On the right side, I can able to show this. This is basically talking about the delays. See, up to 7 minutes expected delays. I mean, it's pretty good the way system is running during this kind of end of the rush hour. And like I mentioned, gaps, anything, we can able to talk about that, So these are the stations. With the gap.
Wind up quickly, Alla. Thank you.
Okay. Okay, and I just want to get it out. And I just want a quick glance, we are adding buses also on this, it will give you a better picture how many people on the bus, which is kind of cool feature. Recently, this is what comes from data from automated passenger counters. So we can tell exactly where is the bus and how many people on each bus. So you can see like passenger count, like right now it's 11. So these are the things, so many options we created on one map, one view, and it gives you a better picture about even a table format. We can able to tell by line, what is the service, like moderate or severe, things like that. And you have a choice like pick and choose any line, So these are the tools we added to this particular map, and we have alerts and everything. So I'm just giving you a better picture about, this is a lot of features we are adding and we are still developing, and it's being used at a few towers, and they can able to see where the trains are and manage the service, and that's what one of the reason trying to improve the performance. Thank you very much. I think that my time is over.
And thank you for that, Alla. I'm going to thank you very much. I'm going to pause for a moment and let our superb technical help here, Alla, give you some information about the Q&A sheet, which is not quite working.
Okay, so the Q&A sheet only for Eddy's presentation about improving local transit connections was not working. We just fixed the issues. We received 2 questions in the Q&A. If you can move them to the sheet, and now it's working. So thank you for these technical difficulties, and we can resume.
So I can able to click on Q&A, okay.
Okay, thank you very much, Alla. You can go back to mute and turn off your video so that we can welcome our 5th and final speaker, Eric Lind, speaking to us from the Metro Transit-Minneapolis Authority. And here you are, and go ahead and share your screen. And you're good.
Okay. Well, thank you, and thanks for a great conference. It's been an amazing few days. I'm really sad that I'm not in Toronto, but it's been a lot of fun. So I'm going to talk a little bit today about well, at least a 6-minute conceptual overview of the kinds of things we do in strategic initiatives at Metro Transit, which is the largest public transit provider in the Minneapolis-St. Paul, Minnesota, USA region. And I'm presenting on behalf of John Levin, who's my boss and the director of the Strategic Initiatives Group. And after watching Alla's presentation, it does give me a better appreciation for the fact that we don't have to actually try to develop a real-time information and management system for our transit network. We have such software that we can purchase from the vendor that allows us to take messages in from the buses and display them in a way that the dispatchers and street supervisors can actually use. Maybe it's not perfect, but it does exist. One theme that's been going on throughout this conference is that when we look at the data that's captured in order to make this management system work, we want to use that data for lots of other purposes. So not just looking at real-time passenger loading, for instance, but to know the historic passenger loading. Apologies, I'm getting hit with a sunbeam like perfectly right now. So what I want to describe is a little bit of how we approach that. So how do we get to the data that the vendor database has and make it useful in different ways or expand on it? Okay. So there are a few approaches to that. And the one that's sort of most traditional or maybe has been used in the past is to basically take the data out of that vendor database, extract it, and restructure it. So maybe change the table structure, change the indexes, change the relations, and load it into another database that you have more control over. So this would be a classic collaboration between, the service planners and the IT department, where you can basically rearrange the data that are being collected and make it more output, what you're actually looking for. And then what happens is it's a very straightforward thing to query out the table or data that you're looking for into, say, a Tableau or a Power BI dashboard. So you've got your tables which indicate on-time bus performance, and you can just kind of pull those out into a nice visualization and make that your KPI. Once you've done that work, and this is really a tremendous amount of work, and of course it comes along with cost, whether it's paying IT or a vendor to do this kind of work for you. But what our group has done is once that data started to kind of become available in that way, we started to look at it in different ways. And by using a little bit more flexible software, looking at R, which can do not only the kind of visualization, but also statistical modeling. And people have talked about using these machine learning methods or other statistical methods to work with data. So we're doing a lot of that. We also want to emphasize that we do this in collaboration. So we use a collaboration, almost software development environment. So we use GitHub for shared code. People can collaborate on code. They can build on each other's code. They can share code publicly in some cases. We can create tickets for developing queries and visualizations. And all of that leads to a few different channels of output. Of course, we can have static reports, websites, and interactive apps. And so a lot of what we've been seeing this week is some of the really cool kind of end user tools. I'll just give a quick example of one that we're really fond of, but this is the kind of thing that we produce a lot, where you've got some choices that you can make about which routes, directions, times you want to see. You use a map to select some geographic area, and you get back some nice statistical summaries, which is something that R does really very well, as well as interactive mapping and things like that. So there are lots of tools that are available once you get your data in the right shape. And I guess that's what the challenge that we have is there are lots of different ways to prepare the data in order to start building these really cool tools. So another way to do this is kind of to shortcut that whole ETL process. So the extract, transform, load, where you've got kind of a formalized IT project to make a formalized reporting database. You can do it more like what we might call ETL in memory. So with the computing power you have in a desktop or even laptop now, you can essentially merge even millions of rows of data from different vendor databases in your programming console. We happen to be fond of the data table package in R, which allows you to do this really efficiently in memory. but there are lots of ways to do this. The central concept is that you don't have to predetermine your data structure when you're talking about extracting data from the vendor database. You can do whatever you need at that one time. So it's very more flexible. Each project can have different data sources combined in different ways. And of course, you can still use that same kind of outflow. So it's a shortcut. It comes with costs, right? So now, instead of having defined kind of pathway for that ETL, you kind of have to know what is inside all of these different vendor databases. Thank you. And how it's structured. And you can do that either by having really good metadata, which is not always the case, or by having people who can kind of go spelunking through these databases and figure out what they're looking at. So that's the cost. You have to be able to merge and manipulate these, which is what our data scientists in our group are really good at. And then you have to kind of do the programming or software management part of optimizing these types of queries. So the last thing I'll talk about is actually moving from not just visualization, but actually quality control of the data. And so using the same kind of process, you can develop an app, for instance, that will check data. This is an example where on the left, you see a histogram of layover time at a certain terminal on a route. The big blue bar on the left is indicating that most of the observations from the standard system are at 0 minutes, meaning no layover time. But we kind of know that it's not all turn and burn. There actually are buses sitting there. What we did is use the AVL and a little buffer around where we know the layover spot is to synthesize data. So the orange bars indicate what we think the actual dwell time is, more like 11 to 15 minutes, okay? So this is a case where we can actually demonstrate that. We can say, you know, for planning, for talking with our operators, no, you have layover time here. Schedulers can use that layover time. But in order to do that, we actually take it one step further from visualization, and now we're actually synthesizing data to go back into a different data store. So these are just some of the ways that we're trying to build on all these amazing data that the vendors are collecting for their purposes, and to turn them in new ways inside our agency and make them useful for people. Thanks so much.
And thank you very much. And thank you very much. That's the last of our presentations. We're going to move to Q&A. I invite all the speakers to turn on their video so that we can see you. And I am going to just go through the questions. And pitch them out to you. Florian, beginning with you. I think the answer to, is this video available for sharing online? I hope that it's been uploaded and will be shared with everybody, as all these presentations will be are either already available or will be available afterwards and be resources to you. So thanks very much. So the first question was a broad one. What is the primary use of TerminalNet for operations or planning?
So actually, it's what I've written, but it's nice to re-explain a little bit, because in 6 minutes was just difficult to get the large scope of it. In fact, you have to imagine that we face a real case that we have that full capacity of the terminal in that station in particular, but we can't address this with only supervisors going on the field and asking drivers to move their buses. It's kind of something that we have to plan and make sure that everything is directed from the beginning, with how drivers should be taking their bus in the bus station or in the deadhead coming to the bus station. So, and at the moment, what we usually have to configure or understand what's going on is when buses arrives and leaves bus stations, but we absolutely lack the information about the time spent on the parking lots. So it's what we had to address, but we had to correlate that information with why the bus had to come to the station. Was it something like a route followed by another route, and we have to leave the bus for a couple of minutes just on the waiting time, just to make sure that everything is smooth and going on the schedule. And at the same time, we here also have movements with buses coming in the station, but leaving, for example, to go back to the garage, and others coming for the garage. With the possibilities of TerminalNet to retrieve all information of time spent waiting in the bus station, we're able to find and develop why buses are coming, and to address the information needed both by planners, which are going to say that we have to add minutes for buses to wait or to in the parking lots, or we have to say that it's going to take less time to get the buses from dead-end to the bus station in order to have fewer vehicles at the same time inside. And also at operational level, because we are going to tell them which movements and at which period of the day they have to focus more, and ask drivers to wait a little bit more before entering the bus station, for example. So
thank
more
you.
on my plan for this.
Thank you for that elaboration. I'm just moving down the line here. Thank you very much. Eddy, here's a question. You pointed out that, and you've had experience, I'm going to point out, working with a couple of our local operators. So what do you think of this? You pointed out that schedule coordination is important in increasing ridership. What about transit agencies? What is their attitude towards schedule coordination? Is it a priority for them to work together? What are the challenges of having them work together?
Yeah, so schedule coordination is definitely really important. As you saw in my presentation, the route that was running every 35 minutes was actually more useful for connecting to the train than the bus that was running every 16 to 22 minutes, just because its schedule was aligned with that of the train. So it's definitely something local transit agencies do care about, connecting people to the GO trains, and they do try to align their schedules. However, for frequent routes, it's sometimes a lot more difficult, especially when a very small portion of customers end up connecting to the GO train. So then there's sometimes not as much incentive for them to do a time transfer kind of thing. But it's definitely something that Metrolinx and local transit agencies are starting to work on and develop strategies for improving. As for policies for holding buses when trains are late, that's something that's generally not done at the moment in the GTA. But again, it depends on the operators and what operations decides to do based on the nature of the GO Transit delay.
Yeah, and so far, no matter what you're doing, they don't have probably the data systems that tell them, you know, like one plane is late and we're holding that plane, and it's not the same operator. Air Canada has to get you straight through, but nobody else does. So
exactly.
Yeah, great. Okay, moving along, and Alla, I have a question for you. I think we're going to still be talking about transfers. In your system, are you able to determine whether transfers are made, for example, from shuttle trains to express local connections? And unmute yourself, Alla.
Yeah, New York City system created in such a way that's what more flexibility in New York. We have many transfer locations. So A division, B division, like I mentioned, 1 line to 2 line or express to local. So that's one of the advantage in the city. And they try to maintain service to make it available, express to local. So when there are major problems and people have opportunity to take, either local or, so that's much more. That's why we try to, sometimes we hold the trains also for the transfers, depend upon the schedule. Mm-hmm. And unscheduled also, we try to see if there is a major incident or anything. Then, the rail control center, they control the service in such a way, make it available to make transfer into local or express like that. It's a pretty common in New York City. That's one advantage in the city, to take advantage of where the trains are, and they can able to look at alternate service.
truly having a system. That's a great thing. Okay, and I'm working my way back. I have a question for Eric, and it's just indicative of the kinds of people we have on the call, the transit people and the data scientists. And here's a question for a data scientist. Can you speak on the key efforts made to develop the in-memory approach to get your data into usable form?
Sure. Yeah, I think that is, well, the real answer is that we have a team of data scientists, and that is what they're really good at, is being creative about combining different data sources in an efficient way. The general approach might be thought of as kind of using that code to pilot getting data into the shape that you want it. So maybe you're only taking a small amount of data from different data sources and kind of trying to reshape it into what you want. The thing that's great about using R, it could be true of Python, other things too, is kind of you can scale up from that pilot pretty quickly to producing the output on a real-time basis, or producing a tool that will query and format the data that you need. So the real effort is in kind of allowing space for these data scientists to kind of figure out the best way to combine the data to answer the questions that the businesses have. And then once there's kind of a working prototype, it's a matter of turning it into more of like a software project again. So making sure that it's kind of refactored and optimized and then can be stable, at least in whatever environment we put it in, whether it's putting it back into a different database or making a tool that's on our Shiny server or whatever it might be. So yeah, that's the real work and skill of having data scientists inside the agency, is to be able to be flexible to do that, kind of no matter what the question is.
Thank you, and that's a great answer. It's like transit, not the oldest profession, but it's been operating for a long time, and it's really exciting to see, you know, different aspects of talent brought into the problem. There's lots of data, and there are lots of interesting challenges, and seeing new people coming in to the field. It's really a wonderful time. So I'm coming back around to the top. Ryan, I have something for you. I'm going to make a couple of comments and let Ryan speak, and then let others comment after. So Ryan, you talked when you began our session, you were talking about multiple standards and the imperfection of some of the data, and therefore challenges in transferring what you've developed one place into other systems. And Eric brought us into the conversation of build versus buy. He followed a presentation by Alla, New York City, a bespoke system. Eric, they've developed, they purchased a system. So do you want to, and I'm going to ask others to comment on this, but Ryan, start with the challenges of taking lessons learned from other people in a symposium like this and transferring them into your own context, and the idea that your thoughts on build versus buy.
So what was the last thing you just said, Judy?
And your thoughts on building a bespoke system that's tailored to your needs if you're for an agency, or buying.
Yeah, okay, sure. So I think it's probably clear from my talk, I lean towards bespoke. I think that when you go down the generic path, you end up losing more time than you gain. So I've seen it occur with different operators or agencies where they've bought a off-the-shelf system, and it's maybe, for example, designed for trains, but they're implementing it for trams, and it's not quite a perfect match, and then you can quite quickly get stuck in a situation where you either have to break your contract and start again, or spend the next 5 to 6 years incorporating this into your organization. And the further you go down that path, the harder it is to step back. So if you go from a bespoke point of view, as say an operator or an agency, you really have the opportunity to engage with a vendor and write your own rules about what it is that you want. If you're clever, you can also actually give yourself the opportunity to change your mind and try and come up with a system where you're encouraging continual development, which is something that you might get with smaller providers with larger providers where they have a very structured software, it can be a bit harder to get customization. So in my experience, I've seen good progress in Auckland using this method. They went through a process where they had the end of life with their old vendor, and then they built a new system to replace it from scratch, and they actually benchmarked everything against the old system. So they said to the new vendor, you have to build something and it has to be better than the previous one, which is really, it's a nice thing for developers, because then you get something tangible to work with, where you're sort of putting your own record on the line as well. And if you're just going down the generic path, the vendors don't really care about their performance versus someone else. They'll just be more focused on, say, the bottom line or the very specific technical requirements. So I think that going bespoke is good in terms of outcomes, and also, like I mentioned, you're less vulnerable to errors introduced by converting a generic system to your own unique requirements. So in some cases, you'll get hard failures, which are actually better, because then you see something straight away, but you do end up with more nefarious problems where something will still pass through your initial set of rules, but it won't be adhering to the intention that you have. And so you'll end up introducing things like incorrect merges on incorrect primary keys, and suddenly you think you're comparing one trip to another trip, but it might be actually a different vehicle with a different start time, depending on something quite inane upstream, like the operator didn't enter in the correct ID or value randomly. So the generic systems they're full of weaknesses for those kinds of problems, and then they have very little mechanism to then address them, even if you do manage to identify.
We have just 4 minutes left. Do any of you want to take an opportunity for a quick comment? We'll go quickly.
I will. I'll just say, Ryan's talk really resonated with me in terms of the flexibility, in terms of using probability, in terms of using different data sources to come to a truth about what you observe. Like that's the kind of thing we're trying to do. We're doing that with internal staff. And so here's my pithy reframing of build versus buy. If we know we have to make bespoke systems, maybe one choice the agencies have to make is hire versus consult. Do you want to be doing that work internally and have people that are really close to the business units? Then you have to find people with the skills to do it, or do you want to rent that expertise from a firm that's doing this for lots of different agencies? So that's maybe one way of thinking about kind of where we're at with the data skills that are necessary to make these systems.
Yeah, really good point in reframing. Thanks for that. Anybody else?
Well, I will be in the same way as everyone about flexibility. One just opinion that it also had the opportunity to try new technology, and for example, just go for a little pilot on some new technology. For example, we're just now researching about how video APC are going to change the way we see what's happening on buses versus traditional APC counters, for example. That's something that you have to do with the business that is developing those new APCs, for example. So we have both in terms of how we're going to collect data and how we're going to use them, and the flexibility to build out elements inside the agency sometimes allows for good relationships on those. And I haven't been talking about the good ideas that are coming out of research, and that we do not have to wait for people to include in the tools. We can already think of how we can manipulate those solutions inside what we're currently developing, and that's a mix that makes a good solution.
The agility and the ability to be working in front line with your business units. It's a great thing. 1 more minute, last comment. Anybody?
Yeah, I just want to explain some of the tools, whatever we built, like this transit visualization. It's a lot of conversation with the operating people and a lot of partnership. It's not something we created instantly, so much input within the operations and their needs. We'll look into that, That's the advantage. Having in-house development team would help, to improve the service also. So they tell us sometimes they don't express clearly, but we understand what we learn from them and build a lot of these things. That's the thing.
Yeah, certainly, right? Actually understanding, extracting what somebody really wants from what they said. It's exactly what I asked for, but not what I want, right?
Yes.
And we gave you 6 minutes only to talk about, the outcome of what was a long effort to build your teams, develop your platforms, work with your business units, and finally share all of this with us. So thank you very much. Eric said he wished he was here. I wish you were all here too. It's an absolutely beautiful day in Toronto. We are ever so sorry that we aren't hosting Transit Data 2020 in Toronto and hosting you here to share Toronto with you. I think it's a beautiful city. I'm a big Toronto booster. I hope when there is an opportunity, you will come to visit Toronto. Our panelists and in the audience that's listening to us, I hope you'll visit our new Transit Analytics Lab, which is up and running, and by the time I'm afraid you're able to travel, we'll have some great things to share out of that. I hope we find opportunities to continue to collaborate together. And I hope you're having a great time at Transit Data. Thank you very much for joining us, and enjoy the rest of the conference.
Thank you.
Thanks a lot.
Thank you.
Bye, everybody. Thank you.